Hi, folks. Somebody said they wanted a quick little video on some of the last couple questions in 6.2, just for some clarification on, good ways to set that up. So this should be, kind of short, but hopefully it helps. So in question 12 on 6.2, 6.2? Yeah, 6.2. Some of the numbers might be a little different from yours, but we have a water tower. That water tower is located 398 feet from a building. So it's 398 feet from some other building. Okay. From a window on the building, an observer notes that the angle of elevation, it's a good word to make sure we're comfortable with. Angle of elevation means angle looking upward from the eye line. So if we say that's the eye line, the angle of elevation, the angle of elevation to the top of the tower is 38 degrees in the version of the problem I have here. And the angle of depression is measured down from a horizon line or down from an eye line. So the angle of depression is 29 degrees. So that angle of depression, 29 degrees. So we could add those together and find that total angle if we wanted to, but that's actually not terribly convenient to do. So we're going to stick with looking at it in terms of these two triangles. Now, the reason these two triangles are helpful is because these two triangles are right triangles. So this essentially breaks into two different triangles. We have the upper triangle, which is 36 degrees, with an adjacent side of 398. And I'd like to know that opposite side. I'm going to call it H1 for the first height. And we have another triangle that's 29 degrees. I'm going to flip it upside down just for my own convenience. Still has that 398 foot difference between them, or distance between them. And we want to find that height. If we find those two heights and add them together, we'll have the height of the entire tower. So if we want to figure out those sides of those triangles, we got to figure out which trig functions to use. In reference to the angles that we know, this is an adjacent side, and that is an opposite side. Similarly for this one, that's an opposite side. This is an adjacent side. Notice we don't care what this hypotenuse is. We don't care what this length is or what this length is. We only care about these lengths because we want them, and this length because we know it. So since those are both opposites and adjacent arguments, they're both going to be tangent arguments. So we know that the tangent of the 36 degrees had better be equal to the opposite over adjacent, so H1 over 398. And the tangent of the 29 degrees has to be equal to its partial height over 398. And again, remember the trig functions all give us ratios of side lengths, or if you prefer, proportions of side lengths. So we're almost saying, like when we multiply this over, we're almost going to end up with the idea that that height is, well, some proportion of 398. Well, what proportion? The tangent proportion. The tangent of 36 degrees. So that product would give us this height 1. Again, multiply both sides by the 398. 398 times the tangent of 29 degrees. That value is going to give us the lower portion below our eye line. So the height in total is going to be that first height plus the second height. So the height in total is going to be 398 times the tangent, I'm just going to write that way, times the tangent of 36 degrees plus 398 times the tangent of 29 degrees. Now, if you want to stay exact, you could just stop there, say it's exact. If you wanted to simplify it a little bit, you can factor out that 398, because it is the same in both terms, and get the tangent of 36 degrees plus the tangent of 29 degrees. Careful, we can't add those together. We'll talk about adding and subtracting angles with trig functions later, but we can't just say that's the tangent of 65 degrees. So we could, so we'd have to stop there. If we want an exact value, either of those would be acceptable, but you're probably going to be asked for a decimal approximation. So you go ahead and give that. I think in this question, you'll also ask, how high is the window from the ground? Well, the height of the window from the ground is the same as that height too. So the height of the window above the ground is just that product of 398 times the tangent of 29 degrees, whatever that value happens to be. And again, the numbers in your problem will be slightly different. But you're asking, how would I set it up and how would I kind of flow through the problem? That's how I would flow through the problem. And probably one of the biggest recommendations, and you'll hear me say this throughout the course, is draw good diagrams. Break those diagrams into secondary diagrams. It will make most of the things we do a lot easier if you get used to that. Some people say they're not visually oriented. That's fine. That doesn't mean diagrams won't help. You know, they might not be as helpful as some other tools would, but the people who are, you know, not language oriented, they still got to read the word problem. The people who are not visually oriented, it still helps to look at and use visual information. So if you're stuck on problems, draw. Draw before you get stuck. Draw. So let me know if that helps or if you need some more information there. The second one that was asked about, question 13, was the lightning rod. I'd almost say, you know, stop the video here, take what we discussed in this problem and go try the lightning rod question again and see if you know, if this way of thinking about problems helped. But so, you know, stop the video, go do that and come back. Presuming that you're still fighting with it, we've got a lightning rod on top of a building. So again, we should start with nice diagrams. So we got a building. That building has a lightning rod on top of it. I'm not worried about drawing anything to scale here. From a location 118 feet from the base of the building. So 118 feet from the base of the building. 118 feet from the base of the building. The angle of elevation, so presumably there's somebody here looking at the building. The angle of elevation to the bottom of the lightning rod is 36 degrees. Bottom of the lightning rod. So that angle, 36 degrees. And the angle of elevation to the top of the lightning rod is 40 degrees. So that angle, I should have drawn them that way, sorry, to be formal. So that big angle is 40 degrees. Now, again, we could say that the angle between them is 4 degrees. And if you wanted to have a triangle that looked like that with a 4 degrees in it, we certainly could. The problem is that's not a right triangle, and we don't know any of its lengths. So while that triangle certainly exists, and while that 4 degrees is certainly the angle between those, it's not a helpful value for us to be working with. What's helpful is the 2 other triangles we have in this problem. We have one triangle that is 36 degrees and 118 along its base. That's this triangle. And we have another triangle that's that same 118, again along the bottom here, but then up along that elevation eye line to the top, and then down the rod and the building. So that 118 with this 40 degrees, that little right triangle. And again, we want this height of the rod. This triangle is going to give us essentially the height, more or less, of the building, but the height to the bottom of the rod. This is going to give us the height to the top of the rod. The height to the top of the rod. So what are we going to do with those 2 heights to figure out what the height of the rod itself is? Well, we're going to take the height to the top, subtract the height to the bottom, and that'll give us the height of the whole rod. And again, we do have to determine what trig function we want, but it's actually fairly similar to this problem. The only difference is in this problem, we added the 2 heights to get the total. Here, we're subtracting the 2 heights to get the difference, just because of the information we're given and the information we want. But we're still looking at adjacent lengths and opposite sides in reference to our angles. So it's still a tangent problem. So really, you know, the angles change and the adjacent sides change, and we subtract instead of add. But other than that, this problem is very similar. Neither of them want this hypotenuse length. Neither of them tell us the hypotenuse length. So no sine, no cosine, all tangent. If you end up really wanting to see the rest of those calculations, I mean, we could write it out. The tangent of the 36 degrees is equal to the height to the bottom of it divided by 118. So we'll multiply by the 118. Oops, that's too many teens. Times the tangent of the 36 degrees is the height to the bottom. The tangent of the 40 degrees is equal to the height to the top divided by 118. So 118 tangent 40 degrees. Make sure you're in degree mode for this problem, by the way. Is the height to the top. Take that height to the top, subtract the height from the bottom. And I'm going to factor out the 118 while I do it. So the tangent of 40 degrees minus 118 times the tangent of 36 degrees. But again, I'm going to factor out that 118. So that would be an exact value. If you want a decimal approximation, find a decimal approximation. Just make sure you're in degree mode, not radian mode. So hopefully that helped. And hopefully this idea, if you're not drawing diagrams, drawing your diagram and your sub-diagrams and make sure you know what you're looking at makes a really big difference. So I often say, when in doubt, draw it out. It rhymes, so it has to be true. But even just as you are reading a problem, as you are trying to understand what the problem is even asking you, drawing diagrams should be an important part of that. And it's a really good habit to get into if you're not already. Okay, so let me know if that helps. Let me know if you need anything else. And I will see you guys later.